Here we go. All right. Well, thank you all for, it's been great again to read more introductions and more, and to see the images you've been working on. And I have to say, you guys are doing a great job. For first tries, you're doing a fabulous job. And we're going to take a look at some of those images. Today, we're going to talk about RGB, red, green, blue astrophotography, how to create images of objects in space that actually reflect the colors that those objects in space actually glow in, rather than using the computerized color maps that you use to make your images this week. So we're going to explore an activity that helps understand how filters and telescopes work. We're going to show you another activity that's kind of fun as a way to help students and ourselves be more observant about the characteristics of an image, to really pay attention closely to the features of an image. And it's an activity called Astro Poetry. And we're going to show you some examples of capstone projects that other educators and kids have done together. Okay. So reviewing the, so from the last, a couple people asked about the homework here. And so your assignment, should you choose to accept it, was to introduce yourself and request some images from the telescopes, process them, and then post them in that forum. A couple of you tried the wiki. I didn't actually show how to do that last week. We're going to do that this week. And then you had the opportunity to join for live office hours. I want to mention that the Zoom link works when we're live, but if you want to look at the recorded webinars, you have to actually go to the educator portal, and here's the educator portal, and the recorded webinars are down at the bottom. So did we put this one up? The last week's webinar, is this it? Oh, that's it, of course. Okay, very good. So great introductions. Thank you so much. It's been great to read those. The images you've been posting, I see here we have online some of the people who produced these images. Rick, great Lagoon Nebula, really did a nice job pulling out all the features. That's actually one of my favorite nebula. And Bushra, I have to say, I had to ooh and ah over your Crab Nebula as well. Let's see, I want, Ria, I want to, actually I'm going to bring those images back. I just wanted to look at a few of them live and show a couple of things. Here we are. Erica kind of answered Janie, showing how to process. One of the things we're trying to do is do some processing of the same images that you're processing to kind of motivate you to try and figure out how to pull more information out of the image. Ria, as I explained, the thing about zooming in with the micro observatory telescopes is that it makes it that much harder to target the telescope correctly. So sometimes when you zoom in, the object is off center. And so that's what happened here. But I thought you did a great job processing it. And the same is true here for Evans. Ginny, you do have the hang of it. Don't worry. Your moon was cloudy. Remember, our telescopes take images whether it's cloudy or not. And great image of the Milky Way. I did some reprocessing of those. Here they are. And so here you can see the clouds that are in your image. So that's all that was going on there. Earlier in the week, the moon was a waning crescent moon, and so it was very thin to begin with, and not very bright. And so if there were clouds, it's hard to see through that. And I pulled out a little more out of your same Milky Way image. So if you want to check into the comments about how to bring out a little more detail using those sliders, I have some information there. Do keep checking the image forum here, and you'll get some tips and tricks for how to improve your image processing skills. And we have on the portal, we have this, does this play? It doesn't play. Ah, okay. We have a movie under the resources about our astrophotographers here at the observatory, and so you might want to check that out. I want to remind you that the images you're looking at are digital, and one of the things I started to highlight last week and that we're really going to pay attention to today is the math behind the images, and this difference between using the linear scale, which is how your images are automatically scaled when you first open an image in JS9, and using the log scale. There's a couple of people on the forum. I wrote kind of a long response, but then said, if it's too long, here's the takeaway of how to get detail. And so here are a couple of images of the Orion Nebula. This is how it appears in the raw data. On the left, and because there's some bright stars in there, remember the range of pixel brightnesses that the telescopes can give are from 0 to 4095, and these bright stars are what we call saturated. There was so much light from that star falling on that pixel that the detector read out a signal of 4095, and then the electronic signal actually spilled, and these little streaks, downward streaks, are from overexposure. So on the left is the raw image. On the right, I wiggled my cursor in the image and found that the background sky was around 290. So I set the low brightness limit near there, and then drag down the high brightness limit from 4095 to 512. And so that brings out a lot more detail in the Orion Nebula, but it oversaturates the middle. And here's what's going on. On the left, you have 256 shades of gray available in this black and white color map. So on the left, the computer is taking those 256 available shades of gray and equally apportioning them over the 495 color brightness values that the telescope sends back. But by sliding up the low brightness limit to 250 and the high brightness limit to 512, all the shades of gray are being used for the brightness values between 250 and 512, which is where most of the information in the Orion Nebula is. But that means any of these things in the center that were over 512 are all being shaded white. So a way to get better dynamic range to see the dim things, enhance the dim things without oversaturating the bright things, is to use that log scale. And so I wanted to just, sometimes looking at the math is helpful, but I wanted to highlight. So here is that same Orion Nebula, same image. So here it is with the linear scale. And here, I pulled down and clicked log. And here you see you get a lot more detail in the center. And what's going on is, rather than that linear scaling of 256 shades of gray across the 4,096 brightness values, we use most of the shades of gray for the stuff that really dim features of the nebula, but we still leave a little variation for the really bright stuff. And so you get to see detail in both the bright areas of the image and in the dim areas of the image. And that's why using that scale feature is good for really dim images. Okay, so I've gone over that tip and trick, and we're going to use that tip and trick when we learn how to use the filter wheels. So you've all taken some images. I've seen some images in your archive, and if you haven't taken any with the RGB filter, do try to find those objects this week. That will be your assignment. Okay, yep, yeah, good. Sorry, Erica's going to connect in from her office. So when you click on red, green, or blue, or all three at once, you're basically telling the telescope to put one of these glass filters above the detector. And so I want to show you an activity that there's a write-up in the curriculum resources that really helps understand how the filters work before we actually create a 3-color image on today's webinar. So to do this activity, okay, of course, now that Erica's in her room, I have to do this all. I'm going to, what I want you to do is I'm going to stop screen sharing. And I want you to find the video of me and pin it on the screen. Because I'm going to be using some filters and demonstrate this activity for you. So I have some gel filters here. The write-up tells you how to get them. And I have a little, I have near my webcam some of these filters on a little wheel that I'm going to put in front of the webcam. And that's going to take the place of, in the activity that I'll be showing you. Actually, I realize I have these earphones on and they're out of my field of view here. Hang on. Okay, the activity in your, this is where I make a fool of myself on webinar camera. The activity is called Alien Eyes, and so for your students, you make these little filters. Wait, I have 2 participants who have raised their hands. Is that because somebody wants to ask a question? No, you're just figuring out how to do that. Okay, good. All right, so here's what I want you to do to start. I have some stars in different colors here: green, white, blue, yellow, and red. 1, 2, 3, 4, 5. And I'm going to take my red filter. So it would be as if you're looking through a red filter, but I'm going to put it over my webcam. I'm going to put a red filter between you and these stars. And I want you to make a prediction first in the chat box. Tell me, what do you think is going to happen when we put the red filter over my webcam? Are these all going to turn red? Is the red 5 going to disappear? Are some of them going to turn different colors? If you would make a prediction in the camera and you know, don't in the chat box, we'll see. So we have a prediction that the white will be red and the red will disappear. I'm going to put a red. Do we have any other suggestions? Let's see, what have I said? I'm going to put a red filter, right? Is that what I said? Yeah, I'm going to put a red filter over here. We have yellow will be orange, right? Okay, so there's a prediction. Yeah. Any other predictions? I'm giving a little wait time here. People are now. I will say that when you do this with your students, I'd like you to write down your prediction. If you're too shy to make it in the chat box, do write it down, because I can guarantee you'll be surprised, because this is something we don't usually think about, what's going on with colored filters. All right, we have a great, we're now starting to get the predictions. Yellow will be orange, okay, blue will be magenta, we're mixing red and blue. All right, so I'm about to put the red filter over the camera here. All right, so sorry, I have to put that down for a minute. All right. All right, well, let's look at our predictions here. So the red did not disappear. We don't have any brown thing. We have green will be brown. Well, the green has kind of disappeared. So the red didn't disappear, but the green disappeared. And the blue disappeared. It didn't turn magenta. So this is kind of some surprising stuff, but here's the key to figuring out what's going on. The red filter only lets red light through. It blocks or absorbs other colors of light. So actually, I'm gonna let you, well, actually, I'll put that back to the clear. So it's only letting red light through. So there's red light coming from 5. So that gets through the camera to you and you see the red star. There's no red light coming from the green and the blue, because these pieces of construction paper only reflect green or blue light. They don't reflect red light. So there's no red light coming to you. So they kind of disappear. They turn dark. Ah, there's an aha out there, yes. And both the white and the yellow piece of construction paper actually do reflect, of course, white reflects, a white piece of paper reflects all colors. So there is red coming through to the filter to you. And the same is true of the yellow construction paper. There's a little red coming through. So when I put that red, right? No red coming from the green and blue, but there's red definitely coming from all these. So now it's time for your next prediction. I'm going to put the green filter over. Okay, let me come back again. All right, the green filter. So now what's going to happen? A few predictions, please. Let's try this time. And remember, the green filter is only going to let green light through. All right, so we have a prediction that the green star will show. And the white will show. The red will pass. So you think the red will come through? You think the red will come through the green filter? Remember, I'm going to put a green filter here. All right, so Karen has a prediction that the green, white, and you think the blue might show too. Okay. All right, maybe the yellow. Okay, so let's see what goes. Let's do it. And actually, before I put the green in it, I have these two Christmas colored sweaters, and I want you to make an additional prediction. I'm gonna put them on either shoulder here. All right, and I'm putting the green filter on. I want to ask you which sweater will appear lighter and which darker when I put that green filter on. Seems to me the green sweater is already kind of darker, but. So I'm putting the green filter that only lets green light through to you. So is there any green light coming from this red sweater? Let's find out. All right. So the green filter, oh, my green sweater, that green light gets through to you. My red sweater is not reflecting any green light, so that can't get through to you, right? And likewise, the red star, there's no red light. That green filter won't let red light through, so the red appears dark. The green filter does let green light through, and there's green coming from the green star. There's green coming from the white circle, and there's a little bit of green coming from the yellow as well. So finally, last prediction, blue. I'm going to put a blue, and this blue filter is a little dark. So predictions about what you're going to see through which of these will appear brightest through the blue filter? I'm going to give a little wait time. So there's a question, white, blue, and maybe the green is reflecting some blue. So so, okay, so we definitely have some agreement, some consensus around the white will appear bright and the blue will appear bright. There's a little question about this. All right, here's the blue filter. Right. And again, it's a dark filter, but that blue does come through and the white comes through. Just a tad of the green gets through the filter. All right, you guys have definitely gotten better at this as we go along, and your students will as well. But to really see if you've gotten better at it, I'm going to give you a challenge, because I have on the back side of this 4 trees. And I haven't shown you what their actual color is. So now I want you guys to observe closely as I change filters and see if you can figure out what color tree number 1 is, tree number 2, tree number 3, and tree number 4. So right now we're looking through the green filter. So trees that have green reflecting from them are going to get through that filter a little, okay? And now I'm going to show the red filter. So 4 is dark through there's no red light coming from 4. There's no red light coming from 2. There's definitely red light coming from 1 and 3. Oh, we have our first guess from Karen. Excellent. 3 is white. You think 4 is green. 2 is yellow, and 1 is blue. We have, okay, so we have a prediction that 1 is blue and a prediction that 1 is red. Remember, we're looking through the red filter right now. So anything that's reflecting red towards you is getting through. Okay. So here's the blue filter. All right. And 2 and 3 are mostly getting through the blue filter. So does anyone want to try all 4? All right, Ginny has tried red, blue, what? Oh, yellow, and green. So we have, oh, 3 is white or yellow. Let's check it out. Excellent job, you guys. Yeah, so we needed to do probably a little more investigation around 3 if, because but it was definitely bright through all the filters. And so that's how you know it's white. Awesome. So that is very important to understand when you're trying to put together a 3-color image. Again, this activity is called Alien Eyes, and you have groups of kids who, some of whom have green eyes, some of whom have red eyes, and some blue, and they're trying to figure out together, after they learn how filters work, what color a scene is. All right, let's go back to my slide. I'm going to share my screen again. Okay, share screen. All right. So the telescope detector cannot tell if a photon, a particle of light coming in, is high energy, medium energy, or low energy. It can't tell if it's blue, green, or red. So in order to create images that are representative of what the real colors in the sky are, we use a technique called RGB filtering. And the Hubble Space Telescope images, all those color images you see from Hubble, are produced exactly in the same way. You take 3 images of the object, one with a filter that only lets the red light through, one with a filter that only lets the green light, and one with a filter that only lets the blue light through. It got a little hot there with those sweaters. And using those filters and combining the images with the JS9 processing tool, you can recreate what the original color of that object in space might have been like, close to what it's like. Again, it's representative of the colors that are actually glowing. Okay, so let's figure out how to do this with the Orion Nebula. And I'm gonna, again, bring my account into the screen here, and my JS9, and I've already loaded my first Orion Nebula. So this is, I took 3 Orion Nebulas the other night. Whoops, there it is, and you can see, it looks like I have the green one loaded. Okay, and another way to figure out if this is the, what image this is to use this tool, Display Fits Header. Remember that I told you that the files that come back from the telescope, there's no image there, there's a bunch of numbers. There's also a header telling you about the image, and I'm going to display that now. Click, and you get all this nice information about the file name, Orion Nebula. And remember, the file name of these images tell you exactly when it was taken. 2017, October 19th, so just the other night. And that's in universal time. So it wasn't at 11 a.m. in Arizona, it was at 11 a.m. in England, which is about 3 a.m. In fact, here's the local time, 3 a.m., 15:31. Also tells you the exposure time for this image was 60, and the filter was, in fact, green. Another thing you can look up in your FITS header, and Ginny, this might have been useful for you, is the weather. The weather number gives you a number from 1 to 100, with 100 being perfectly clear skies and 0 being terrible. Sometimes even with a value of 90, if the clouds are right in front of your object, you're out of luck. But this does give you some indication if your image isn't good and you think it might have been the weather. All right, so this is the green image. So we have to tell the computer it's green, and we'll do that in a moment. But first I want to enhance the detail. And remember, to do that, I say, I'm going to click log. And that's going to enhance all the dim parts of the image. But of course, the background sky is dim too. So I have to set that low. The second step is to set the low brightness limit at the value. And you can see here, it's around 320. So I'm going to type in 320 and hit return. Return. Ah. So yes, I have quite a bit of detail in the Orion Nebula. And this, I'm going to tell the software, this is the green filtered image. All right. Now I'm going to open my blue image here. All right. And again, those same steps. Log scaling to enhance the really dim stuff. Set the low brightness value at 322. Enter. Ah, there's all that nice detail. And now I tell the computer this is my blue image. So I have two images loaded. If you look up here, see I have two images loaded, one that's blue and one that's red, and they're behind each other in the software. Now I'm going to load that third red Orion Nebula. Here it is. Log scale. Set the low brightness limit to 330 around. Hit enter. Oh, that red is really nice. I get a lot of detail in that. Tell the computer this is the red image. Well, now how do we see all three of them together? Under color, you click on RGB mode, and the software adds the three images together. It's as if you were shining red, green, and blue lamps on the same screen. You add the light together. And so let's do that. Ooh, very nice. Okay, but now you see that the telescope wasn't perfectly aimed for these three images. So I need to shift and align the images with each other. And there happens to be a tool for that. It's called Shift. So I'm going to open up the Shift tool. And the Shift tool works on whatever image is active. And you can tell what image is active by looking at the color scale below. You can see that this is the red image. So I'm going to shift that red dot. Watch the dots up. Actually, if I open the magnifier at the same time, you can see I'll have try and have there we go. So I'm shifting up and over. Okay, so now I have the red aligned, and it looks like, oh, it looks like the blue could go a little bit to the right. See if I look there. So let's make the blue image active. The color bar is blue, and I'm going to shift that over to the right just a little bit. Let's see if I can. I'm having trouble getting let's see. That's pretty good. I could probably do a little bit better, but I'm pretty happy with this image. And the Orion Nebula actually is fairly pinkish. It has a lot of hydrogen, and it turns out that the element hydrogen glows with a very pinkish glow. And so one of the things astronomers learn from the colors of objects in the sky is what they're made of. They can also learn things about how hot they are. If you can see, some of these stars are bright and bluish. Well, this star is a little orangier. That's because of the color. Here's a very red star right here. And that's a very cool star. So you can tell temperature, you can tell what things are made of, all of these things from color. Once you have your RGB image, you can do a little post-processing. And in fact, if I go back to my red image, I feel like I'd like to make that, oops, what happened? I want my red, there it is. There it is. I want to make that a little bit brighter and more intense. There we go. And I want the background a little darker. There, that's nice. So I like that. I'm going to use a region tool to add a label. Some of you figured out how to do this. I double click and write my text, Orion Nebula RGB. And here's something, a new tip and trick. I don't want my text to be green. I want it to be pink. So these 6-digit style numbers are actually an indicator of the color. And JS9 is actually smart enough, if it's a simple color, that all you have to do is tell it pink. All right, apply. So now I have my label. I'll close it up in pink. And I'm going to save that as a PNG. Save that in my documents, save, okay. And now your mission, should you decide to accept it, is to take your own RGB image, process it using the steps I've shown here, and then post it. I'll create a forum post that you can reply to, but right now I want to show you how to create a wiki page, because that's one of the features that is a way that your students can share their own work through their own wiki page. So in order to do that, I'm going to go back to the main page. I'm currently in the youth portal. I'm going to go to the educator portal and make a wiki. There's a question from Ginny, do we choose RGB filter when you request the image? That's right. You can't, if you, the actual image has to have been taken from the telescope where there was an actual red, green, and blue filter. You can apply the red, green, and blue color maps in JS9, but if you do that with 3 images, let's say they were 3 Orion images taken through the clear filter, and you make one using the color map, using the software, you make one red, you make one green, you make one blue. When you add them together, you'll get another black and white image. It'll be just the original, because you have to you have to have images taken with filters so that different light is actually hitting the detector. Red light is hitting the detector of the telescope for one image, and so on. Let's see, how did I mix the 3 colors, Mary? So the steps I just did on the webinar, first of all, we're recording this so you can watch the webinar again. But the how to make an RGB image is also a tutorial in the in this Youth Astronet forum. If you look down here, tutorials and other useful video, I open that up, you can see there's a tutorial on creating a true color image. So you can look right here. And with regard to, yes, you have to, when you take the image request, the Hercules cluster, you won't be able to get a true color image of, because we don't give you the option to take images through the red, green, and blue filter. So you have to find the objects for which we give you that choice. So the Ring Nebula does give you that option. This you can make a true color image of. And most of these nebula, you have 3 color image choices, but this globular star cluster does not. So you have to figure out which are the targets that allow you the 3 color choice. All right. Good, so let's now make a wiki page and upload the image of Orion Nebula that I just made. So I'm gonna go back to the educator portal, because I'm gonna make a wiki page on the educator portal. Your students can make their own wiki pages on the student portal. So I'm gonna add a page, I'm gonna add my own page to this wiki that we've created for the whole group. So I click on it, and you can see the wiki page has separate pages within it for all these educators that have been with us before. I'm going to create one, I'm going to create my own page, and then I'm going to go edit that page, and here's how you do it. Again, there's a tutorial on creating a wiki page as well that Erica has created. So I click on edit, and I get a text box, a text editing box, and you can see that here's the October cohort. I'm gonna click return, and to create a page with a link to it, the wiki software, the way you do that is you use double brackets. So left bracket, Mary Dussault, since we have a Mary Dessau, Mary Dussault's October image wiki, right bracket. So that's all you have to do to create a link to a page that you will then go in and edit. And so if I scroll down, I'm going to save. And it leaves this bright red stub. So when you see that bright red stub, that means the page has been initiated, but it hasn't really been created and edited yet. Okay. So here's how you do that. I'm going to click on that and create my page. All I do is just click on create page. So now I get to edit my page, the Mary Dussault's October image wiki page. And I'm going to say, hi there. Here is my RGB image of Orion that I made during the webinar. And I can get fancy with that if I want to make it some special font, or if I want to color it, or all sorts of things. And then I'm going to insert my image again with this mountain icon in the upper right of your image editing toolbar. So I click on that. I'm going to find and upload the image from my desktop. I just downloaded it as a PNG file from JS9. And I think it was in my documents. That's where we put that. Yep, there it is at the top, my Orion Nebula PNG file that I made. Notice that when the JS9 downloads an image file, it preserves that original date it was taken, and then adds the exact time that you happen to have downloaded the PNG file. All right, so I'm uploading that. All right, and there's my image in there. Give it alternate text description, Orion Nebula. There, that works. I've used that before. Okay. So here's my image, and I don't want to take up that much room on my wiki page because I might want to add another image to the right. So I'm going to highlight it and shrink that a little bit. Right. And I could add another image to the right. I can keep editing this page in the future. When I have a new image, I could add a new one in there and keep going. So then I save. And there's my wiki page. So now, if I go back to the original wiki cover page, this is the page with all the educators who've made wiki pages, and I click on my link, there will be my page, and I can edit this page to add more things as I wish. So that's how you work with a wiki page. I want to note that there is one funky thing that happens with the Moodle software and these wiki pages when if all of you educators tried to make your own wiki page at the same time, sometimes Moodle gets confused. When you're making a cover page for all your students' wiki pages, one thing that you can do, one thing a lot of our educators have found success with, is that they go in advance, click edit, and add all the names of their students and create the initial stub for the page. And then their students go in and edit their own individual pages. Okay. So that's how you make a wiki. And Mary, you can see now that if you go into your page, you can edit it and upload your image there. And Leslie has already figured out how to make a wiki page and has uploaded at least one image to it. So feel free to share your RGB images with us in either way. You can either add to the share your processed image wiki, or I will also create a new thread right here. In fact, I'll make it right now. Add October cohort, add your RGB images here. I can't wait to see them. All right, so reply to that post or create your own wiki page. All right, let's see. Okay, in our last few minutes here, we're gonna now do the Astro Poetry activity. And for this activity, let's see, this is where you're gonna need to find your chat box. I learned this activity when I used to work at the Museum of Science in Boston, and one of my colleague educators always used to use it as a way of getting students to really observe different exhibits. Like if they were at the T-Rex dinosaur, she'd use the activity there, or if they were looking at some interesting object. And so we're going to use it looking at this interesting object, which is not the Orion Nebula taken by micro-observatory, but rather by Hubble Space Telescope. Still, this is not so very different from the full-color Orion Nebula I just made using micro-observatory images. And again, the technique is exactly the same. So here's how the Astro Poetry activity works. I'm going to ask you guys to look at this image and start to brainstorm some words that it remind you of, some adjectives, some verbs, some nouns that come to mind as you look at this image, and use your, so look, we've already got thanks Mary, so we have colored And I'm going to actually make a new, in case we want to move that, colored val. Oh, rainbow, clouds. Somebody else is doing this. Thank you, whoever that is. Rainbow clouds, thunderstorm. Okay. Swirl. SWRL. Oh, good. Whoever is doing that, thank you. Nebulous, yes. Somebody, folks have figured out how to use the annotation. This is excellent. Great. All right. You guys are awesome. I love this group. This is great. So let's see. We have rainbow. We have some adjectives and some nouns. How about some verbs? Swirl is a verb. Has some more verbs about what's going on there. Floating. Oh, good. Okay. Floating. All right. Flying. Oops. Flying. All right. Any other? Birth. Yes. Excellent. All right. Now, I see some obvious words that aren't in there, so I'm going to put them. Pink. Magenta. Excellent. Some colors, right? There's colors. So you want to observe what you see in the image, really simple things too. So, great. Phoenix. Okay. So it looks like now here, okay. We have gas. Gas. Bright. Good. All right. Awesome. All right. This is great. Let's stop here for a minute. Now, oh, Misty. Okay. Maybe someone can put that up. Although what I notice is I can only move the words that I seem to have put up here. Is that true? How am I doing this? Oh, wait, no, I can move them all. Oops, wait, go back. Select. Oh, good, I can move them all. All right. So if anyone wants to type in the chat box a first line made up of some of these words. If I were doing this with students, I might give each groups of students a stack of Post-its or note cards. So does anybody have a first line? Oh, Mary, colorful blowing winds of wisdom. My goodness, okay. Well, we didn't have those words. Swirling phoenix, floating high. Okay, so Phoenix, see, I'm moving these around. Swirl, and I don't know, I can't edit. I have to, swirling. Somehow I can't edit at the moment, so I'm gonna, you can see how this would work. So I'm gonna do my select tool, swirl, Phoenix, floating, and we'll just add a word. High. Okay, and then we have expanding gases, expanding. All right. See, now you're adding new words, you guys. You have to work with the words. Let's see. Expanding gas. Right. Moving in space. We'll just imagine that's there. So right now, I'm using the annotation feature in the Zoom video conferencing software. As I said, when I've done it with a class of students, they all have Post-its, and we put the Post-its up on the board at the front, or you guys might be able to suggest different ways of doing this. Some educators have liked to give teams of students the same set of cards, and they all come up with different poems. Using Wordle, that's a great idea. So you can see that here's an activity where it helps students create captions for an image that they may have created if they can't figure out how to caption it. It's a great way to produce a astronomy exhibit. So I find it to be a nice activity. All right, I'm going to erase, I'm going to clear everything here because I think when I, let's, how do I clear? Clear all, okay. So let's move forward. Here are some examples of student capstone work. These students not only, they're collecting Hubble images of the same objects that they made images of, and they're creating here's a sculpture of the Crab Nebula. So they're creating 3D parts of an exhibit. This is a educator whose students were actually, their capstone work was to focus on how the telescope they were using worked. So they made they did some design engineering challenges of trying to engineer a telescope. You can see this little filter right here coming out. So they're trying to have a little model of a telescope where you could put different filters in and look through this eyepiece. Here are some examples of Astro poems and captions that were added by students in the YouthAstroNet program. I like this. 1 inch of flying stars seems like an image of a flying saucer. So these are all, here's a moon project looking at the phases of the moon. This was one of our educators worked in an art museum and had students make these little contact sheets of all their images and create this universe in a box, or this universe chain. Here's another STEAM project where students took their JS9 processed image up here on the right and then created a painting inspired by it. So they used their observation skills to create paintings. So there's lots of different options for capstone projects in YouthAstroNet. Here's our students had a family night and were showing peers and family how to use the microobservatory telescopes and how to process images. Here's some fancier exhibits created. This was for a library. Here's a low-tech exhibit for a family night. And here's a high-tech exhibit. These were students at a museum that had some of the resources to be able to create polished graphics from the students' work. So these are all examples of what we call a capstone, YouthAstroNet capstone project, and I wanted to give you some examples of those. In the educators portal, I think we have our Microobservatory Mondays webinars recorded, and in those we end up working with veteran YouthAstroNet educators to talk about some advanced tips and tricks and things that they're doing in their classrooms. And of course, you are all invited at any time to attend those webinars as well. In fact, we have one coming up on Monday. But those are recorded as well and kept on the educator portal. Ginny asks about the resolution of these images in terms of how much they can be blown up. And that you've probably already seen, even when you zoom in on them in JS9, you can't make them too big. So you notice that in all these examples, students kind of created a collage of images rather than trying to blow one image up very large. So that you can certainly make 8.5 by 11. By the time you get to 11 by 17, the images start to get a little bit low resolution. Okay, well, that's today's webinar. Your next steps are to continue checking out the educator portal. The checklist, the next item in the checklist is to create your own RGB image. Keep contributing to the discussion threads. And your capstone, one of the things we try in this little 2-week online workshop is to model a YouthAstroNet program for you educators. And so your capstone is to create a wiki page. In fact, if I bring that up here, let's see, in the portal, you notice we have your capstone project is to create a wiki page where you start to think about how you might implement. And so here you can see we had someone actually just started their capstone. I think we have some that are okay. So there's someone talking about what they're going to do. Some people included images in their capstone. All right. If there are, oh, here's where we are. This was today, webinar number 2. Next week on the 24th, we'll be showing you some activities, do a little Q&A, and actually be showing you some other activities like our design engineering challenges. Our design engineering challenges using little bits. And we have kits, we have classroom sets of these electronic kits that we actually can loan to YouthAstroNet educators. We'll ship you a classroom set, availability dependent. It's first come, first serve. So we'll talk about that next week. And then at the end of the week, Erica, there'll be office hours and times when you can talk with Erica about signing your students up. So are there questions, any more questions out there? All right. Well, thank you guys. You guys, I really love to see your work on the educator portal. This has been so fun. If you can't attend the live webinars, we record them all the time. So it's always available for you on the educator portal, no problem. And the schedule of webinars is also on that portal. So if we go here, you can see, and this will it's listed in Eastern time, and depending on how your computer is set, it might tell you your local time, but all the events are listed right over here when they are. All right, well, I'm going to stop the recording, and